This episode of Fluid Power Forum is sponsored by eShipping, a distribution chain management company offering transportation, warehousing, and technology services. Learn more at eshipping.biz.
I see the need for a lot of these mobile manufacturers to really take a look at some of the new products that they're launching within the next few years, and how are they going to fit within these new standards provided by the global environmental market.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, subscribe and then give us a quick rating. That really does help more of our friends in the industry join in on these important conversations. On today's show, our guest is Jeremiah Alshouse. Jeremiah is a product manager of element technology at Schroeder Industries, a manufacturer of hydraulic filtration technology. And Jeremiah was a speaker at one of our recent quarterly conferences. You can learn more about those conferences by visiting our hub at nfpahub.com. But today we invited Jeremiah into our forum to hear more of the content from his presentation, which focused on Schroeder's work with electric hydraulic systems in mobile equipment. Jeremiah, welcome to Fluid Power Forum.
Thanks for having me today.
We're glad to have you on the show. I'm hoping that you can tell our listeners a little bit more about yourself. What do you do at Schroeder and how'd you come into that position?
So, like you previously mentioned, I am the product manager for the Element Technology Group at Schroeder Industries. So pretty much after my college years, I spent the early stages of my career assembling and testing hydraulic components for subsea equipment and various steel mills. I was approached by Schroeder in late 2017 about an opportunity to expand my knowledge base about the world of hydraulics with a position as an application engineer who assisted all of the product groups that we offer with various projects and trainings. Eventually, I progressed through Schroeder Industries, and I had a calling for our filtration elements division and worked my way up to product management position that I currently hold today.
I'm going to want to hear more about your calling to hydraulic filtration. But are you a trained engineer? Where did you get your initial training?
Yes. So I attended Penn State University, the Barron College, which is a university branch campus located in Erie, Pennsylvania. And that's where I attained my bachelor's in mechanical engineering in 2015. I had a few varying courses and labs that did revolve around the basic concepts of fluid power and energy systems. So that kind of led me into the early stages of my career, where I, kind of fell in love with the idea of hydraulics and wanting to learn more about them when I was assembling them and testing different components.
Yeah. What is it about fluid power that you find so exciting, if I can ask such a provocative question?
I always found, fluid power and hydraulic systems fascinating when it came to the schematics. So when I, was able to operate hydraulic power units and wanting to dive deeper on how they worked and how they performed on the various components that I tested, I just found it really interesting and wanting to learn more.
That speaks to me. I'm kind of a geek when it comes to hydraulic circuit diagrams. They're among the coolest things. They're like a puzzle and an adventure story wrapped up in one. If you really learn what's going on them, so that's good to hear. So tell us a little bit more about Schroeder Industries. What kind of company are they? What do they do?
So Schroeder Industries specializes in designing, manufacturing, and marketing a complete range of what we refer to as advanced fluid conditioning solutions. And we have been doing that for over 75 years for a vast number of markets and applications.
What can you give us a sense of what markets the company operates with?
Mining, agriculture, oil and gas, refuse, construction, mobile vehicles is a big one, and so much more. But those are just a few.
So mostly on the mobile side, it sounds like.
Yeah, pretty much.
So I mentioned in the intro that you spoke at one of our quarterly conferences not too long ago, and I remember you talked a little bit there about something called Schroeders 2030 initiatives. Why don't we start with a tighter description on what that is?
Okay, so as a filtration manufacturer and engineering firm, we've always lived by the idea that clean oil can really make a difference in this world. As sustainability becomes a much larger conversation in this world, we're hoping to start a revolution designed to change the narrative of sustainability in the hydraulics industry with what we now call our 2030 initiative. So as more and more organizations aim to be carbon neutral by a certain date, we chose 2030. We wanted to reiterate that importance of proper fluid cleanliness.
When was this started? Was this started recently or within the last couple of years?
So right at the beginning of 2020, it was an idea that was proposed by our marketing team, and it was kind of a way that we are seeing a lot of other companies right now transition and wanting to do better for the environment and for the planet. So that's something we wanted to kind of spark that idea on how we can actually do our part. And one way, as an American manufacturer to some of the most versatile green material, we wanted to make it our goal to kind of spread the word and share our technology that is proven to support carbon neutrality and all their initiatives for 2030 and even beyond.
Well, I was curious, like what kind of time horizon did you envision? It sounds like it was a 10-year. If it started in 2020 and you're aiming at 2030, we hear about these kinds of initiatives in the marketplace all the time. I mean, here we are in early 2022, and it's really something that is changing the landscape in a lot of ways. So you think another 8 years is going to completely transform in the sustainability area?
Absolutely. Right now, we currently have products that can help support that idea. You know, as technology keeps evolving, we find new ways to help this initiative along. So we believe in 8 years we can provide a great grasp of knowledge and technology that we want to share to help other companies do the same on obtaining carbon neutrality.
Yeah, let's get into some of those products and some of those new initiatives. But maybe before we get into those details, let's talk a little bit more about. You said earlier that most of your markets are in the mobile hydraulic side. So what are some of the things that are happening in that space that are helping to drive this? There's obviously a need at the customer level for these kinds of sustainability initiatives and changes. Why do you think that's happening at the OEM level?
Well, I think you see companies nowadays like Amazon and Tesla that are kind of reinventing the wheel. They're showing that you can have a mobile car run strictly on an electric driven operation that's much better for the environment. And now with new strict environmental standards that are happening across the globe, I see the need for a lot of these mobile manufacturers to really take a look at some of the new products that they're launching within the next few years and how are they going to fit within these new standards provided by the global environmental market.
I see, I personally see a lot of this innovation and drive happening in California right now. So there is, and I think that's mostly from government regulation. They're passing
Absolutely
new laws that further reduce the emissions and further require greater efficiencies. And that used to be very much just an on-highway thing, but it's increasingly becoming an off-highway thing as well. Is that also what you're seeing?
Yes, we are definitely seeing it in both scenarios, both on highway and off highway.
Are there any? What do you think are the unique challenges in the off-highway space for these mobile equipment manufacturers to be dealing with when it comes to these changes?
I think when it comes to the biggest challenge in these mobile industries, when it comes down to pretty much the cost of what I'm going to have to do to modify my equipment or design a completely new system. So the cost to modify their products to support somewhat of an electric driven operation is much more expensive than the traditional hydraulic components that we currently see today. So adding in the cost of all of these different components is daunting on these manufacturers. So that's why it kind of inspired us to come up with solutions that can help them save on their overall costs while also assist them to achieve that carbon neutrality in the process.
That's great. Yeah, I mean, we see a lot of electrification projects, if you will, some of which are still very dependent on hydraulics as the actuation technology on these machines. And as you just described, there's a lot of new technological challenges associated with those electric power sources connecting to and continuing to get the efficiencies that they need out of the hydraulic systems. It sounds like you're right on. You're trying to address that particular issue, if I'm hearing you right.
That's correct.
Yeah. Well, great. Well, let's pick up that conversation on the other side of this break, Jeremiah. We had to take just a quick break here to provide our listeners with an update on some other fluid power industry opportunities. All right, we're back from our break. I'm talking with Jeremiah Alshouse of Schroeder Industries, and I think we just laid the groundwork pretty well for the market need for sustainability, lower emissions, greater efficiency on off-highway vehicles. And I know you want to talk some more, Jeremiah, and we want to hear some more about what Schroeder is doing to help in that space. Is it beneficial for us to talk in the context of an actual example, or how would you like to approach what Schroeder is doing?
Yeah, we can go into somewhat of a niche market here. Yeah, we can definitely do that.
So give us an example of a concrete example of a kind of machine that's benefiting from these technologies.
So a good example of mobile hydraulic machines that are looking to implement somewhat of an electric-driven hydraulic system would be somewhat in the refuse market. The hydraulic systems on garbage trucks, per se, are a great focus of some manufacturers to implement these as they see the big potential for savings on all fronts, whether it be cost or on-highway environmental reasons.
So this would be an electrically powered garbage truck rather than one powered by an internal combustion engine.
Well, this would be one more the fact to have their hydraulic system be electrically driven.
Oh, but still have the internal combustion engine on the vehicle?
Yes, you can have a combination of both. It really depends on what they're actually trying to do. You can have a completely electric driven operation instead of an internal combustion engine, or you can have a combination of both.
So are they what is the electric power source? Are we talking about a battery or an electric motor, or what typically is the device that's being used then?
Yes, you can use an electric battery powered with kind of an electric motor pump group.
Okay. Tell us a little bit more then about that configuration, if you will. How is that usually set up?
So pretty much how these are generally set up is an electric hydraulic driven system. They tend to be a little bit more efficient than traditional hydraulic systems. When you think of like a car that has a high efficiency engine, you're at a stoplight and they're not in motion for a period of time, the car's engine turns off to conserve the amount of power that is using until you're ready to use it again. So that same concept can now be used in hydraulics. When it comes to a garbage truck per se, the electric hydraulic motor pump unit can only operate when flow and pressure are required to perform the working task at hand. So like lifting bins or compacting any trash.
So it sounds like a powerful advantage to only access the hydraulic system when you need to use it? I'm imagining a garbage truck does a lot of driving around without having to lift the bin, right? So, but is there any disadvantage to doing that way? Is the power not available when you need it? Do you have to wait a second for it to kick in? How does that work?
Actually, no. Electric-driven operations can act a lot quicker than standard hydraulic methods right now. Most electric-driven systems have controllers that can pretty much act in an instant, so there really isn't that much of a delay. They really don't see anything different as far as a performance delay on that end.
That's great. I think you mentioned that these configurations can be, or maybe are, more efficient than the more traditional configuration. So is there any, can you quantify that in any way? Like how much efficiency gains are we talking about?
Yeah, absolutely. So when it comes to the efficiency of an electric-driven hydraulic pump motor unit compared to any traditional units, original tests from different manufacturers show anywhere between 60 and 70% more efficient than their standard hydraulic counterparts. So depending on the overall use and longevity of the hydraulic system, that will ultimately help determine if these OEMs would benefit from that switch.
That's a significant number. So usually you're looking for, single digit gains, but 60%, that's pretty impressive.
Yeah, absolutely.
So these applications are still using hydraulics to perform the actuation functions, the heavy lifting, the power density that they need. And that's still going to be the case for a while, don't you think?
Yeah, absolutely. These hydraulic components are pretty much here to stay for the long term, but it's just a way of how we are going to use an electric driven operation to actually power these hydraulic components. So, with these electric driven operations, one thing that is to be considered is, why they're so much more efficient, up to 60 to 70% more efficient, but they're extremely costly. So, if we're a way to integrate these coming up with a package solution where it comes with all of these hydraulic components with the electric driven operation, that's a way where we can help cut down on overall costs to the OEM. And now they can actually receive a serious consideration when total cost of ownership is looked at.
Yeah, increasingly it's that total cost of ownership, as you're saying, that's becoming the driver in all these conversations in a way that it wasn't in the past. So Jeremiah, let's talk a little bit more then about some of the contributions that Schroeder is making in this environment. What specific products are you guys making available for these applications?
So, being a custom engineered solution manufacturer for a wide range of fluids and applications, we're pretty much able to come up with a vast number of products that can support different hydraulic operations, from custom tank T&K packages to fluid monitoring equipment. We have pretty much solutions in place to help aid in the function of an electric hydraulic driven system to ensure that they're operating efficiently and environmentally friendly as well.
Mm-hmm.
Being the product manager for our filter element technology group, one things that I can share with you, something that we are currently working on, is our electric drive media, or e-drive media for short.
Mm.
This e-drive filter media consists of an all-new multi-layered fiber filter media that can help assist in the smooth operation of an electric-driven hydraulic motor pump unit.
So to be clear for some of our listeners, Jeremiah, when you talk about media, you're talking about the material inside the filter that actually does the filtering, right?
Yes, that's correct.
And so you're talking about a new kind of material entirely, or a new configuration of materials? Tell us more about how it actually does the magic.
So pretty much what we're talking about here with eDrive Media is a new configuration of media layers kind of stacked against each other.
Okay.
There's plenty of different filter medias out there in this world, and we want to make sure that we have the best of both worlds in this case, to make sure that we're providing the best level of filtration technology to any electric driven system.
And the filtration needs for an electrohydraulic system are different than a regular hydraulic system. Can you tell us more about that? What are the specific needs in that space?
Yes. So when it comes to any standard hydraulic component, obviously the biggest drive in filtration technology is to make sure that you're actually pulling out the particulate that is harmful to that specific hydraulic component.
Yeah.
So having a high level of dirt holding capacity and having a very high beta ratio to make sure that you're removing the particulate that you need is very crucial when it comes to any hydraulic component.
Right.
But the extra need that we have with electric driven operations is to maintain a low pressure drop throughout the filter element and the housing itself in order for the motor pump group to work more efficiently.
Mm. Okay, so I'm going to test my engineering knowledge on what you just said there. So the pressure drop, again, is the fluid pressure before it gets to the filter and then after it gets to the filter. Anytime fluid goes through any kind of component, there's some drop in pressure as it makes its way through the configuration of that component. So you're trying to reduce that as much as possible to drive more efficiency in the system. Is that what you said?
Differential pressure, like you described, pretty much describes that loss of energy available in a
Right.
hydraulic system. But however, the energy really isn't lost, rather converted into a thermal energy, which is unavailable to really do any perform any useful work. So if we can minimize that loss of energy or that transfer of energy, we can actually utilize the electric pump motor group to its best ability.
Yeah.
So that's pretty much that's one of the major reasons why we're going at this filter media itself.
And this has been shown to reduce that pressure drop as much as anywhere, I'm assuming.
Yeah, so our initial targets is compared to normal like synthetic microglass media that is found in a majority of filtration elements today.
Mm-hmm.
We want to actually be lower than that but still maintain a high level of efficiency and dirt holding capacity that is shown with synthetic microglass. So we're trying to get the best of those scenarios to really make sure that this electric driven operation can perform smoothly while not having any lack in downtime due to contamination.
Did you mention where you are in the development? Is this a product that's ready for market, or where are you?
So we are still within the testing phase. We obviously want to make sure that we have the right technology that's going to offer those great characteristics like I previously mentioned. But our goal really is to have the first element rated for 10 micron filtration to be released by the end of this year.
By the end of 2022?
Yes, by the end of this year, 2022.
So I'm curious, you guys must have your thoughts, you must have your crystal balls there. Like what do you think the future of this technology is going to be? Is there going to be a quick adoption in the market for this?
I would say it's going to be an immediate need. When it comes to a lot of these electric driven hydraulic components and systems overall, they're just being released into the market or just being talked about. A lot of these standards are pretty new and they need to meet an end goal by a certain date, whether it be 5-10 years from now.
Mm-hmm.
So I feel like if we can get ahead of that initial need and we can provide that knowledge to these customers when people are actually manufacturing these pieces of equipment, that will give us a major advantage that we have technology that is ready to go.
That's great. Yeah, it's important. I guess that brings us full circle. That brings us back to your 2030 initiative, right? So making sure that the products that the market needs are there and available for them when they need it is the alchemy that you're trying to create.
Yes, absolutely.
That's great. Well, thanks, Jeremiah. We very much appreciate your time on the show today. Any closing comments for our audience?
Yes. When it comes to electric hydraulic systems, I see a very bright future for them as more and more companies move toward carbon neutrality. the need for these electric hydraulic systems increases. So how are we going to help our planet and become more efficient in this industry as a whole? And I think we are in a great, area, and we're stepping in that right direction. Whether how fast it goes is pretty much up to us all.
Absolutely. Well said. And we'll be keeping an eye on that, obviously, as these developments move forward. So that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Jeremiah Allshouse, who has been my guest. If you'd like to connect with him and learn more about what he's doing and some of the new products he talked about, the best way to do that is by his email address, and we're going to put a link to that address in the show notes for this episode. And if you're looking for more content, like what we've just discussed with Jeremiah, as I said, he was a speaker at one of our quarterly conferences. We have those happening every 3 months, and you can learn more about those conferences by visiting the NFPA hub at nfpahub.com. Remember, if you like our podcast, please follow us on Twitter. We're there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with that hashtag #OnlyFluidPowerCan. Fluid Power Forum is a podcast of the National Fluid Power Association. We are ably produced by Maddie Parise, NFPA's Communications Manager. And I'm your host, Eric Lenke, reminding you to join us next time in the forum.